So section 3 of 4, there's only 4 sections, deals with the circles and something called a tangent line and a chord. And the nice part about these tangent lines and a chord is that they have the same properties as what you just did in section 2. So if you've already kind of figured out how worksheet 2 works, worksheet 3 is going to be very similar to it, except that the pictures are going to look slightly different. So first thing I want you to know, a line tangent to a circle touches the circle at only one point. This right here is called the tangent line. It touches the circle exactly in one point. This line is tangent to the circle. There are a lot of different properties about it, but first thing you should know is that it's a straight angle and it's equal to a total of 180 degrees. So that's important for us to know. If it's tangent, it's a straight angle, it's going to be 180 degrees when we talk about a tangent line. It also only touches the circle at exactly one point. It may look like it's touching a whole lot of spots, but it's exactly in only one point. A chord is a segment with 2 endpoints on the circle. This part here is called the chord. So I'm going to put chord right here. And I'm going to call this the tangent line over here, just so you know what parts are what. A chord is a segment that has one edge on the edge of the circle and the other endpoint is on the edge of the other side of the circle, which is pretty much why guitar players, they call it a chord, because certain sounds across that circle of the guitar make a certain sound. They call that a chord. If there's any musicians in here, that's something that means the same thing in both worlds. A chord versus a chord. It's a chord. Okay. A chord segment is a segment with 2 endpoints on the circle. We talked about that. Any chord that intersects at the tangent point. When this intersects at that tangent point, this angle is half of the intersected arc. So if this is 100 degrees for the arc, that angle is exactly 50 degrees. 100 degrees for the arc, the angle's 50 degrees. And then if this is 260 degrees for the arc, half of it is 130 degrees. These angles are half of that. Or if you double these angles, they will be equal to the intercepted arc. Either way is correct. Sometimes it's easier to double something. Sometimes it's easier to just to do half of something. So, very similar to what we just did in section 2. Examples I have picked for you, number 4, 8, 12, and 15. 4 examples. Number 4. Here's your tangent line. Here's the chord. If the chord is touching the tangent line in one spot and this is 70 degrees, then this is half of the arc it intercepts. Sometimes you can think about it in terms of half. Sometimes you might just want to double it. I would do 70 times 2. X is going to be 140 degrees. Because half of 140 is 70. It works. I chose number 8. Why did I choose number 8? Because the hardest that it gets is when they have 2 sets of algebraic expressions, meaning this angle or this arc is going to be 18x minus 4, and this other angle is 8x plus 6. And so what do you do when they don't give you an actual measurement for that arc or that measurement for that angle? You have to use the properties. So this arc is 2 times as big. Half of this is equal to that. But instead of dealing with fractions, sometimes it's just easier to double the smaller piece. This angle right here is 8x plus 6. If I double that, it should be equal to the 18x minus 4. So that's how I'm going to start. I'm going to double the smaller one and set it equal to the arc. This is the exact same thing as taking half of 18x minus 4 and setting that equal to 8x plus 6. Either way is correct. I just think it's easier to deal with the whole number instead of dealing with the fraction. But you could do either one. Doesn't matter. If I double the smaller one, don't forget to distribute and get 16x plus 12 equals 18x minus 4. Subtract 16x, subtract 16x. You would get 2x. Thank you. Add the 4. Divide by 2. Now, as a person who has worked in Clovis Unified for 18 years, I can tell you that this worksheet has you figure out what x is, but a lot of times when you get to the test, they don't just ask you for x equals, they might ask you, what's this angle and what's that angle? So don't forget to find out, or don't forget to look back at the question, because by the time you get to the test, they will expect you to plug this back in. And not saying that that's going to happen this test, but definitely that's what happens a lot. Number 12. The arc is 124. They went back to an inscribed angle. Are they equal to each other? No. This is half of that. You can do a half of 124. Half of 124 is 62 degrees. If that's 124, that has to be 62. That means the 10x plus 2 has to equal 62 degrees. We can subtract 2. Oh, that's easy. It goes in nice and even. They were really kind to us and gave us a nice, easy, even answer. Last example is number 15. They threw in what's x, and they gave you a 7x, a 7x, a 12x, and a 10x. And you look at all those central angles, because their vertices are at the center of the circle, where that dot is. So if I think about it, this is 7x, and this is 12x, and this is 7x for the arc, because they're equal to each other. You should know that these arcs have a total sum of 360 degrees, just like we learned in the first section. So what does that mean? That means the 7x plus the 12x plus the 7x plus the 10x should equal 360. 14, 26, 36x is what I'm getting. 7x, 8, 9, 10, 19, 26, 30. Yeah, that's what I get. 36 times x equals 360. Divide by 36 on both sides. 36 goes into 360 10 times, which is easy. But by the time you get to the test, don't forget you'll probably have to plug that back in and figure out what arc DC is, what the angle is, and so on. I'm going to stop your notes right there.